All right, so we've got a couple questions over here. If you have a question, just line up over there. I see a couple people already there, so go for it. Take it away.
Hi. This question's probably for Guillermo, but anybody else, maybe if they have some opinions too. So I have a pretty large application which has users and communities and things like that. Once in a while, a user will go onto the page which says like list all the users in this community, which in the novice sense emits a whole lot of get XHRs, like one for each user. I've turned that into a batch request to get all of them at the same time, but it still is going over the regular HTTP connection. But I also have socket.io running for real-time updates. And I was thinking about it earlier today. I was wondering if it made sense in any way if the socket.io connection was actually a WebSocket connection to route some of these XHR requests that would normally go through the regular HITIP connection. Is that a sort of thing that would be stupid?
Yeah, definitely. I've seen a lot of people do... I mean, if you're using Socket.io, you're doing it right, so definitely. No, I've seen a lot of people do this, HTTP over WebSocket. I think when it comes down to specific optimization, like the one you're mentioning, there's a lot of things to consider. One of them is, if you're making tons of XHR requests in parallel, Speedy solves this problem really well, because it allows you to push resources, it allows you to multiplex. It also does compression. So by turning on Speedy, you might get an immediate win there. The other thing to consider is, of course, on the other extreme, which is ditching HTTP requests and just requesting them through some sort of event or RPC call of sorts. So I think the thing that's most important there kind of goes back to what I was mentioning earlier is on that page, you sort of know what requests are going to come. And it's optimizing around that. Maybe not so much optimizing around the client requesting, but the server sending without the client requesting itself. Does that make sense? Okay. Anyone want to add something? Yeah. Maybe say definitely? I don't know.
Definitely. Yeah, and I think Guillermo touched on the point that I was going to add there, that the routing for the responses could, you could find a lot of efficiency by having those be routed back to your app with Socket.io. So yeah, you would have response events and sort of dynamic events all coming through the same channel.
All right, probably for Erik and Dan, excluding some of the optimizations that Trevor talked about, I would like to know the ratio of front-end programmers who become fully functional, full-stack programmers versus the more server-side Java, C++, .NET, whatever sort of experts who then become functional front-end people. So it's the ratio of one to the other.
Very complex question. All right, so there's two questions there. 0%? Okay, 0%. No one needs to be full stack. All right. I wanted to highlight that on this panel here, there are at least two front-end developers who've become back-end developers, and that would be myself and Trevor. 50%, right? And then were you back-end first?
I don't remember.
Full stack.
I was front-end and back-end, but JavaScript got me interested in, I think, optimizing the entire network stack. And I think that's a cool opportunity with Node. You might start with, or JavaScript in general, you might start with something very, very front-end based and then do whatever you want, like control a drone or Arduino or write an entire OS TCP stack in JavaScript. So 0%.
Specifically for Erik, within PayPal, you probably have some data points here. Front-end people who became serving their own data versus people who were responsible for serving data becoming front-end people.
Yeah, it's an interesting question. I think, first of all, full stack changes depending on where you go. So when I think full stack, I think front-end developer, I think web application, what did you call it? back end of the front end, the back end front end engineer,
front end,
back end engineer, the mid-tier engineer, and then somebody that knows database level stuff. Like that's full stack for me. So if you break it down that way, I don't know that we have any I don't think we have any full stack engineers at PayPal because we have a service-oriented architecture, and we intentionally segment people that have those disciplines on purpose. That said, if you're really talking about mid-tier, potentially mid-tier or application level engineers that have, I almost said graduated, that's not the right term, but that have embraced front-end engineering, and then front-end engineering application, front-end engineers that have embraced application development, I think it's kind of an expectation that has been set, and most everyone has made that transition. One of the things that we did during that transition is we acknowledged that maybe everyone doesn't want to do this, and that's okay. And we moved that criteria down to if you just want to work on, air quotes, backend, then there's plenty of mid-tier services, applications that you can work on. But if you want to work on the front tier, that's great. Really all that is aggregating services, aggregating data, and basically transforming it into a format that you can use, and plucking off the values that are important to you and representing that for front end consumption. So I think we've had really good success in it. I don't know, there's the whole we can reuse JavaScript on the front end and the back end. I don't see that I've seen any actual. I don't see that I've seen that in practice that's actually added a ton of value. But the fact that all of our front-end engineers understand async programming with JavaScript automatically put them a step ahead when getting into Node and understanding how Node APIs work, how talking to services work, and just the mental model around working at the back end of the front end tier. I think we've seen really good success with it, just from that perspective specifically. The corollary of seeing Java engineers that haven't necessarily worked. They may have worked in futures, they worked in multi-threaded applications, but to make that jump to async development, and not just like higher order functions or Lambda, like, oh, I can pass functions around and it looks async, to actually grokking and understanding async development has been, I'm not going to say it was a challenge, but it wasn't as natural from my experience. Is that fair enough? Right on.
Riffing on Erik's talk, the great thing about the way the stack's evolved and Node and front end JavaScript, it's really given us opportunities to be creative and sort of solve. We're engineers solving the problems that we want to, scratching the itches that we have, solving those problems. So we now can go and accomplish those in new and unique ways. Encouraging or forcing engineers to move one way or the other, I think is the wrong way of thinking about it. Giving opportunities to grow and expand your experience, your knowledge and understanding is what Node has provided, and I think that's really compelling.
Hello, my question is more about the hardware. You mentioned in the presentation that you were able to reduce the number of servers like a half, while you had all your application written in Java and you moved to Node.js and you were able to reduce the half of the server. So my question is, what is the optimal setup of a server that you will need? Suppose you have one high-end server, like 128 gigabyte of RAM, two 10 gigabit Ethernet, and like 40 CPUs. So how you would chop into the virtual machines? What is the optimal way so you get the best performance, maybe that sweet spot?
I think that the question was predicated on a comment I made, but I think everybody can probably chime into this. My very short answer is that it has absolutely nothing to do with the hardware profile, and it has all to do with how you design the system and specifically that application. And the thing that I referenced, the particular application, the profile of that application was way more amenable to a Node stack than it happened to be for the JVM. It wasn't necessarily about the hardware profile, wasn't anything else. It was that specific app had the work that it did just was in Node's wheelhouse, and the framework that it ran on on the JVM just was a square peg in a round hole type of situation.
Question is that, you know, the Node.js uses one thread, so it's better to dedicate one CPU per virtual machine. So then comes the question, how much RAM it's better to dedicate to application server, and how much, I don't, depending maybe on network or
okay, so
capacity.
To address that, Node is single-threaded. So the general rule of thumb is one node process per core. Given that you're only running Node, right? The V8 heap maxes out at 1.5 gigs by default. And so n cores times 2 is way more RAM than you'll need. So if you're running 40 cores with more than 80 gigs of RAM, you're going to be like, I mean, I hardly ever see hard-hit applications using more than 800 megs of RAM, right? So 40 cores and 60 gigs of RAM should run you fine if you're running 40 node processes.
Just a small editorial side note, if your application runs on 2 boxes that have 80 cores or 40 cores, you're kind of setting yourself up for failure, in the sense that if one of those boxes goes down, you're kind of SOL. So I think, at least for what we've experienced, the optimum is actually running more smaller boxes. You're more resilient to any outages or any issues that may run. So I think how do you optimize gigantic hardware may be answering the wrong question in a way.
So I would encourage you to not think of your VMs as just a single Node app. You're setting yourself up for a monolith. So in each one of your VMs, you may have multiple apps multiple processes doing and orchestrating amongst themselves. So unfortunately, it's one of those sort of not very satisfying. It depends, but I would encourage you, not to think of a single core, a single process. Let's slice it, those 40 cores up into a single process and a single VM, or 2 can work in some of those situations. But really looking at how each individual deployment works effectively will color how that gets carved up, and it'll probably vary from application to application what the most optimal profile of your VMs is going to look like.
Actually, I was most interested the ratio between the network and the RAM memory. So if you have good network, if you want to keep a big load on this one node, then how much the RAM? Sorry?
There's no ratio.
There is no ratio.
It completely depends on the work you're doing. If you're just passing data through, I mean, I'm not crapping you. If you're just passing data through on a Node app and you're handling 10,000 connections on the box, I've seen Node processes run under 100 megs of RAM, right? So, but if you're doing template rendering and you're doing the same number of connections, you could be using 800 to a gig of RAM, right? There's no possible ratio that is statistically significant in terms of how much bandwidth you have and how much memory you need.
The best approach is benchmarking before going live?
Yes, yeah. You need to know the limitations and use case of your app to be able to determine that.
Thank you.
This question is for Guillermo and any other member of the panel. In your presentation, the issue of real-time came up, and really real-time. Have you considered setting real-time to, say, some common denominator, like 20 seconds, so that no matter where you are in the world, real time is always 20 seconds in the past?
I was going to include something in this presentation, which is the research by Nielsen on how we react or how long it takes us to react to data changes. And I think that's a meaningful addition to how we assess speed and real-timeness of applications. It roughly goes like this. If it's under 0.1 seconds, the user has a feeling that he's interacting directly on the data. This is the case when you use Excel on a local machine. Like everything that you do is instantaneous. You think you're altering data directly. And you sort of forget about the persistence aspect of it. And he says under 1 second, to most human beings, what happened was instantaneous. That's why I advocate for not showing spinners or loading indicators unless a significant amount of time has passed. Because to most people, under 1 second is instantaneous. I've trained myself to recognize that, for example, my PS1 variable on Bash was taking too long. It was like 50 milliseconds off. But most human beings that are not staring at their terminals all day think under 1 second everything is instantaneous. So, and then he says over 10 seconds, that's the limit at which you lose your attention span and you like tab to something else. You open Reddit or Twitch.tv and you just do whatever you do something else or like yeah. When you guys were working the previous question, it was somewhere else. No, just kidding. So I think it's there's a theoretical basis to how we can assess like how real time an application is, which has to do with okay, so the server learns of a change on the data. How fast can we get it to users? That's why I was saying that as long as your application is self-updating and fast, and it could be fast just because you're close to the server and you're polling, right? Or even if the page was just refreshing automatically, if the right conditions are set, your application does feel real time. So yeah, I would go from that angle to assess how real time an application is. But I found that the best way to like define it has been it has to be fast and the user has to learn of the changes to the data without doing anything.
That's all fine for the biomechanical implications of a circuit, such as your finger taps on something, you feel it, your brain, and so on. But if we're just talking about setting the present to 20 seconds in the past, then you could theoretically bring everything that happened on the server down to the client 20 seconds in the past, and then that person would always see the present as it already happened.
I don't follow that. Maybe you do.
So we're all so tied up into trying to get something transferred from a server to the client.
Right. Oh, you're saying if the client doesn't know that data has changed, to them it doesn't matter how fast they get it? Is that?
They already have it. It's already happened 20 seconds before they got it. Before they even saw it. They already received it.
Maybe. Like data sampling?
Okay, so yeah, I've actually seen this, and I think I know what you're saying, where it was actually updating by the second what was happening, but when I look at the code, what was happening is that it was sending me chunked 5-second updates and then updating 1 second, but technically the data was 5 seconds in the past, but to me it looked instantaneous. Is that what you're saying?
Yes.
Okay. All right.
All right. So I think I think that's important because a lot of what we talk about is optimizing the experience, right? But I think the most important optimization we can make is have the power to decide, right? And that's what server push allows us to do. So even if we can get away with tricks like that, if we don't have server push, we can't do the most optimal way of sending data, because maybe we want to send it right away after the server knows, maybe we don't, but if we have the right architecture, we can make the choice, whereas if you're stuck on some older architectures, you can't. But other than that, I think that's answered. You want to add something?
So a couple of years ago, I went to a session on Node.js, and they were talking about SSL termination at the node tier, and that one server failing could take down or make the entire cluster compute bound. And I wonder if that's been addressed.
No. So this is what you're describing is actually a very I know the exact scenario that you're talking about because I lived it at Voxer. So that issue is in part very, very specific to Voxer's architecture. So in order to maintain the rich real-time experience, there's a lot of session affinity. So the fact that there's that session affinity, all of the SSL termination, the SSL handshakes is very CPU intensive, and so if you do, tens of thousands all at the same time on a single process, and everybody is coming back to the exact same node, then you're going to be in a world of hurt. So that's a challenge very specific to that particular architecture. But the SSL termination story in Node is still not great. We've made improvements in what will be 12, but it's incremental. But typically in large scale applications, the SSL termination is done off the process, and if you look at the proxies all the way down story, there's a reasonable argument to be made if you don't need SSL throughout your stack to do SSL termination. Off the process. Do you want to talk about some of the SSL termination stuff? That you. I can a little bit. Okay. Okay. Let me let Erik talk about that.
So prerequisite for everything at PayPal, obviously, is security. So we do use SSL all the way down. We were proactive in making the decision that we don't do any SSL in Node, partially because it would be a performance bottleneck for us. But as much as it's like a warm, we love the Node community type of this is how it operates thing, it actually is true. It's not a core competency of our apps. In the same way that running cluster is not, like understanding how our deployments happen is not a core competency of our apps. So like forcing our apps to do SSL, forcing our apps to do gzip, that's not an application level thing. That's a system and infrastructure level thing. So it's just worked for us. And I think Dan was alluding to some other things that we've had to do to improve SSL performance since we have an N-tier architecture and doing SSL all the way down is really expensive regardless of your implementation. But we've definitely decided that those are not like core features that our apps need to be concerned about. So we've done everything we can to pull them into extra layers. So terminated Nginx and then reverse proxy into Node, for example. Let things that are good at gzip do gzip and not force that through the Node pipeline.
Yeah, I was going to add something specifically because we do it in the same way at CloudUp and Automatic. Even from a modularity perspective, it makes more sense to always consider your applications just a vanilla HTTP server. And even if you decided to handle SSL in Node, it would make more sense to stack it with other modules or processes and wrap those servers. So in our case, we do it with Nginx, but if Node becomes better at it or we just want to do it in Node, we could. But your application should just export the lowest common denominator, which would be just listening on some port and exposing just HTTP.